Hi, everyone, especially to the ones that are a little bit hangover. Thank you very much for coming. My name is Manu, and I work as a software engineer at Builder.io. I building APIs, SDKs for my last 12 years, all sorts of things, game engines. I build stuff for iOS, backends, everything. And recently, I'm working in the framework team, building a new kind of framework with an amazing team. Mishko, he's the creator of Angular. Adam Bradley, he was the director of engineering at Ionic. And some random AI hallucinations that we will not talk about. So you might be thinking, why another framework, right? And it is a very interesting question. When I was first pitched about Qwik, it was not in the state that it is today. We have a meeting. I have a meeting with Mishko. I was about to join the company. And I had exactly the same question. I was like, come on. But it really does something that no one else does. And part of my job today is two things. It's give you a new mental model to think about a problem in a different way. So it doesn't matter if you're using Qwik or not. My idea is to give you a new mental model, and also to prove to you how is it different and why it makes sense and we need this. So this is a slide I always use. This is information from Web Archives. It shows that in the last 10 years, the amount of JavaScript has been steadily increasing. And when you look at the 50, this table is not very important, but you just have to pay attention that in the left column, everything is red. That's bad. And green usually means good. What it means is that pretty much the 50 biggest e-commerce in the US, they all fail in terms of performance. When we try to improve the JavaScript, or we try to optimize the images and CSS, in this table, we see some sort of delta, how much we improve. When you improve the images, there's very little improvement. This website is already doing a very good job at optimizing images and CSS. But when you optimize JavaScript, the improvement is massive. You improve like 60 points, and you automatically almost get to the green area, which means that the JavaScript is the bottleneck. And this is really a problem. Well, this doesn't matter what you have here, but the idea is that performance connects directly to how much money you can make, especially if you're a business that sells directly to customers. If you have a slow website, you are leaving money on the table. So why is this happening? And there's many theories. You will have a lot of talks about performance. Everyone has a different idea of why this is. Some people say this is a lack of diligence. Developers are lazy. They just do whatever. They don't know whatever. Or the framework you choose is slow. I disagree with this. I think the problem is because the current DX, the current developer experience, is flawed. And first, we need to respond, what is developer experience? What is developer experience to you? One can be like achieve more with less. It can be something easy to understand, minimize mistakes, good documentation, scale to bigger teams, scale to bigger apps. And this is very important to make developers happy, right? You use a framework that you enjoy, that you want to work and you can be productive and you actually enjoy. But what is not is performance. Performance is something else. Performance is, well, kind of a chore you need to do afterwards. And that's where the problem relies on. That's why things are slow. Performance is a trade-off. You are building an application and you need a lot of things. The things might come from many stakeholders, right? It can be your boss, it can be the CEO, it can be the marketing department. You need A/B testing, metrics, animations, functionality, 100 million things. Then another constraints, you want to have a nice API. You want to choose something that you enjoy. So maybe something can be their React, but it can be any other thing. It can be Vue, it can be Angular, whatever you like. Pretty much all the frameworks will live in this intersection. If you want performance, you want to ensure performance, like 100 out of 100, instant time to interactive, maybe you choose something like Astro. Astro lives in that spot. That's their sweet spot for Astro. You have a very nice DX, people love it, and you pretty much get performance by default. You cannot fuck it up, right, if you're using Astro in terms of performance. Maybe this is obviously my personal opinion, but I think if you use something like HTMLX, it's a bit more niche, and it will be between capabilities and performance. I will agree that that's not in the DX or API. It will not be a framework. It's not a framework that focuses on that. And it doesn't have all the learnings of all the most popular frameworks in terms of what developers like and love. The thing is that in between this intersection, there is nothing here. And you can tell me, look, I can make a fast website with React. But then that will be kind of you. You will be putting a lot of extra energy. And I'm talking React, and I'm talking about other frameworks. Of course you can. You can make a fast website with React or with any frameworks, but it doesn't happen out of the box. And you can just see this from talks about 20 amazing tricks to make your React application faster. You need to know all these things. So we used to say that there are two types of companies, those that prioritize performance at all costs and those with bad performance. Just think about this for a minute. Think about, for example, how, who knows here, for example, Linear. It's like a Jira alternative. Linear, anyone? So, Superhuman, there's all these kind of apps that they focus on performance, right? These companies focus on that. They put so much resources, so much engineering time, so much money onto that. That's why. Otherwise, in your company, depends what the focus is, it's not going to be like this. So all these can be explained by the, a principle of nature. Who here knows what the principle of least effort is? Maybe from high school. Okay, come on. We are a bit sleepy. Anyone knows it? It's right there with the glasses. It's like a bit. It explains the shape of the thunderbolts. There's a differential potential, and electricity flows, and it goes through the path of less resistance. And that path has this shape. Crystals, the atoms arrange in these orders, in these shapes, because there's the position that minimizes the amount of energy. People are lazy, right? So this is just an example. You can make all the paths, but if you can just skip through, people will just do that. And it's not anything you can do about it. It's almost like a nature rule. Trees is a very interesting one. Trees has these shapes because it's the design that minimizes the amount of material, and at the same time they can get as much surface and as much light as possible. In fact, some of these designs are being used for 3D printing. So one of the latest ideas is when you make support, use or imitate these organic shapes. And turns out that these shapes take less amount of material and takes even less time to print this support. And it's all taken from nature. So this is you, and you are a React developer. So what will be your path of less resistance? I will say it's maybe use effect. You can just use effect, you can get the job done. You can do a lot of things with it. So, but we know that might not be, we all know maybe that this is not the right way, but we just use it anyway because it gets the job done when nothing else works and you don't know exactly what is the right solution. We know that this is probably full of performance food scans, but we do it anyways. Why do we do it anyways? Because of the principle of less effort. The problem is that pretty much existing frameworks, the path to you from an empty state, from a scratch, blank application to a fully functional website, the path of less resistance, the path that most developers take, is not the path towards a fast website. You have to put a lot of extra energy to go through the top of the mountain to achieve this good performance. So this explains why things are slow by default. It's not a technology problem. It's a design problem. So again, when you move there, you are getting away from that API circle, and then you're getting into the capabilities and performance. I used to say that the best developers can write horrible code. And I think sometimes when you go to a company, especially like a startup, and you look at the code base and the code base is a mess, I actually think that's sometimes a very good thing. Good developers find the path of less effort. They will not waste time on things that doesn't matter. And it's not a lack of diligence. It's not a problem of putting the blame into the developer. When you go, this is you, when you go from empty state to an application, you will go in a straight line, but in reality, and everyone that works in a company, especially if it's a startup, it's many constraints, there's limited resources and time, there's limited experience, your developer doesn't maybe know everything. You have a boss that tells you that this needs to be ready for tomorrow. The path is not a straight line. So one of the philosophies in Qwik is that don't blame developers for what the frameworks did. We put too much blame on, you need to know all these things, and if something is slow, it's your fault, but we disagree deeply on this. Qwik is the first one that has a fundamentally different way to look at these problems, and it allows to write complex instant application at a scale without extra effort. And the extra effort is the key thing that differentiates Qwik from anything else. From an authoring perspective, it's very, very similar. This will be a Qwik and React component. Pretty much if you are, I will say even if you are not a React developer, the same, let's say, authoring model of components will be very natural to you. It's not something completely different. And that's why Qwik still is in the DX. We want to build something that people love to use. It doesn't matter if we build something that is fast, but then it doesn't have a nice API, it doesn't have a good developer experience. We will be back in that shapes, we'll not be in the middle. We will be still choosing where, for example, HTML5 is. This graph is very, very interesting. I put it in all my talks. This is from a blog post from Ryan Carniaro, from the creator of SolidJS. And we have different applications from 1 up to 280 components, and we see how big these applications are. And then we prompt it in a graph. And there is very interesting things. All of them has a linear slope. This means that as the number of components grow, the amount of JavaScript goes linearly. And notice that it doesn't matter which framework you choose, right? If you have a very, very small application, let's say, 10 components in the page, maybe it does matter, right? If you use Svelte, it will be very, very small. Or one component, that will be so small. But as you grow, it doesn't really matter. Like, actually, it's funny because Svelte is the one that scales the worst. And it has the reputation of being the smallest one. But only if you care about, okay, I have a couple of components. So the rest will be pretty much the same. Qwik is the only one that has a 0-1 scalability. It's a flat scalability. So it doesn't really matter if you have 80 or 1 or 5 or 500. It will be still flat. See? Yeah, there we go. It's the first 0-1 framework with good DX. The good DX is important because this idea already exists. Google, for example, has an internal framework, Wiz, I think, that is being used for Google search, for Gmail, for the very, very complex applications that they need to be fast, but they don't have a nice DX. In fact, it's a little bit of JavaScript with Java, duplicated logic, and they need like the whole, let's say, tooling at Google to be able to deploy it. So it's not something that people like. In fact, Google doesn't use it for everything. They only use it for the things that make sense. So the good DX, again, very, very important. One of the things I want to explain is how does it achieve this? Because it seems too good to be true. So who here knows what hydration is? I guess from after the party, everyone knows what it is in terms of drinking some water, but in terms of front end? Okay, good. Okay. For the ones that don't, hydration is basically the process that happens always in the context of you run some code in the server and then in the browser. So it needs to be always in the context of I run my application in the server first. And it's being used by all the system, let's say, popular frameworks. It works the following way. You have the root application, and from that root application, it needs to keep walking the tree up, downloading the components, executing, and at the very end, you have the event handlers, and the user can interact with it. This whole process is time and downloading things that happen. Until all this time, you cannot click. And everything here needs to be download it, and execute it. It doesn't matter if you use lazy loading. If it's in the page, it needs to be downloaded and executed. You might recognize from the previous tree, I'm going to play again, that some parts of the tree are static. The black dots means component that doesn't have any functionality. So for example, the side of the footer will be a completely static part of the website. So why executing and downloading? This realization is recognized by partial hydration, that popularized by Astro. It's a huge improvement because now you don't have to execute and download every component. Instead, you can say this part is fully static and then break your application into little islands. But these little islands of interactivity still need to download and execute. And still, there is some time until the event handlers are ready to be clicked. You can split it, and you can say, well, there is something else that can happen a little bit later. So it's actually a massive improvement that you can do. I want you to pay attention to these dotted lines. These dotted lines represent work that you need to do. These islands doesn't happen out of the box. You see where I'm coming with this? If you are limited on time, you are not going to make this. You are not going to, this partial hydration doesn't solve the DX problem, the human design problem for you. It's a very nice API. It solves a problem from a technical perspective, but it's still work that you need to do. And if you have your boss telling you that you need this tomorrow, I'm sure you that you are not going to do that. React Server Components is very much the same idea, but there is still a single root. So this has a very nice properties because you can communicate very easily, very naturally between different parts. There is no islands, everything can communicate. And still you can save all these like nodes from hydrating. The difference is kind of like the work of how you split your application. Instead of being in islands, let's say vertical islands, you could from the root. It's more like partial hydration will be I could my arm, my other arm, and here will be like I could horizontally my application. I think it's kind of a nice way to think about it. But still, very, very similar. As I said, you can communicate things between different parts of the tree without any extra effort. So that's nice. I know that in partial hydration and Astro you can also do it, but it has to be supported by the framework of choice. Resumability is instantly interactive, and that's it. There is no walking up the tree. There is no going from the app, going up. It doesn't matter if the component is interactive or not. It's almost like we flipped the tree, and the event handlers are the first thing that is there. The components are not there. In the other models, you need to start with the components, with the tree, and the last thing always is the event handlers. In resumability, is backwards. So the application almost behaves like, okay, what kind of data structure this looks like? The other one is a tree. But this can look like, anyone can say anything? I'm going to, okay? What? Thunder. It's more like a hash map. You think about it. It's a key value. It's almost like these keys, the events are the things that can happen, and then immediately maps to something, to a component, to something interactive. That's kind of the key innovation of how this, let's say, way of putting things allows O1. Hash maps is a data structure that allows this kind of scalability behavior. But thank you very much for, for being the only one that give a chance here. In theory, I love this phrase. In theory, there is no difference between theory and practice, but in practice, there is. And going back to the previous example, your boss is here, and see, the marketing needs a new button in the header to hide and show the newsletter form from the footer. And it's like, what? Why do we need this? So time to refactor. You spend all this time making these nice islands, and now you're coming with a new requirement that allows to this beautiful footer that was full static. Now it cannot be. So you make a new island, because you have this little component that is interactive. But not only that, you need to communicate different parts. So you end up making a bigger island where you have the header and the footer, and kind of, the job that initially did is kind of a little bit lost. I really love this. React components happens a little bit the same. You start with this empty starter, everything is beautiful, and then after a while you end up with use client everywhere, because it's what happens. It's not a problem of React, it's just like nature. So my big idea for you to take today is that systemic performance issues cannot be solved with yet another API. We cannot give more options. More options will not solve the problem. We need to solve the problem at the DX level. You have to, about changing the resistance. You have to reduce how much effort requires to build a fast website. You might have that make it easier. But another nice way is to bad patterns make them harder. Like something that developers should not do, it should not be the easiest thing for them to do, basically. And I think it's reasonable. So now that you've been introduced with the whole idea, I can just show you a little bit of a demo. So let's see. So what I'm going to do, I'm going to create a small Qwik app. I'm going to start with that. Can everyone see the screen, the text? Good? OK. So I'm going to create a Qwik app. I use pnpm or npm create Qwik. Yes, I'm going to call it, let's see, because probably I already have Armada JS 1, Armada JS 2. So I'm going to put Armada JS, maybe even with this, it could be already a folder with that name. So, OK, so we select a starter, basic app, installing dependencies, yes. OK, initialize new Git repository. OK, finish install. You want to hear a joke? Yes. OK. Oh, I already finished. Let's see what it was here. We can. OK. Well, sometimes it's actually a very good joke. So it's just the best random. So let's open the project. Armada. There we go. I'm going to open VS Code. I'm going to make this a little bit bigger. And I'm going to run the command that was suggested, which is pnpm start. Let's see. OK, so we have this application. The first thing, even in development, this application doesn't download any JavaScript. So I'm just here. There is a bunch of images and CSS, but there is no JavaScript. This application doesn't download any JavaScript. But let's check it out. This application, we have a meta framework called Qwik, which is very, very similar to something like Next.js or Next, where you have a file-based routing. You have components. These components can be fully interactive, all of them. There is no difference between some sort of server components or client components. Every component is exactly the same. They can have interactivity. And pretty much it looks like a React application. There is nothing I did here special to make it faster. However, there are things that can be interacted. Notice that there is no hydration. Nothing happened yet. But I can click something here, and it will be 71, right? Just interacting with this component. And when I did that, a bunch of things go downloaded. So one of the first things that downloaded was this little one. I don't know if you can see it well. Maybe a little bit bigger. Oops. OK. What it was downloaded was literally, this is the only code that got downloaded. It's almost like I optimized my application as much as I could. But if we look at the original code, let's see where this is. I think it's in the hero, maybe. Oh, no, let's do that. Let's do one little cool thing. Where the code is, I can actually have this feature when I click on it, and it will actually guide me directly where the code was. So if I click in Control and click in any part of the file, I will actually jump into where it is. So that actually saved me some time now. Notice that this button is here. It's on click, and there is some code. It's part of my component. I didn't break it up into different files. However, Qwik managed to pull this out. And when this happened, it downloaded the core, the Qwik core itself, and then that's it. That was the only thing that happened. In fact, the component itself was not downloaded. How that can be? I will show you. I will dumb it down a little bit and just start with a very simple thing. So I'm going to create a new button, and I'm going to say click. I'm going to put on click and say console log click. Okay, following? Everyone is respected, nothing weird, nothing exciting either, but okay, where the button is. Okay, it's here. So when I click this, there's only one thing that got downloaded. It was literally the click. There's nothing else that happened. We didn't hydrate, nothing else happened. This is very simple, right? I should be able to put, I'm going to put here some console log and say re-render. This code was part of the component, right? In fact, it executed in the server. But this code never, ever executes in the browser. Notice that the console open, we see the click, but no the re-render. It's like this code itself was never downloaded. We can interact with a component, and that component itself was not downloaded. But let's make it a little bit more complicated. I'm going to actually make some state. So I'm going to use const count, use signal. Use signal is a way to create state. It will be similar to use state. And I'm going to bump it the value plus plus. At the same time, I'm going to put here, I'm going to print the value. So let's see what happens. So click 0. If I click on it, click 1, 2, 3, you see this happen, but at the same time, see that what didn't happen. The render didn't even execute. That's crazy. We can actually make a component interactive, and this component, nothing, removed. Oh, a bit bigger. The whole thing. Nothing get to the browser. But do you notice that I didn't have to do anything special? I don't have to optimize. It was just the normal way to do things, you know? Another cool demo I want to show is a little app I built, which is called Promptly Art. So this is kind of like Wordle. I don't know if you know this game where you have to guess the names. And the game, oh my God. Let's choose something else. It's kind of a random picture, so let me just, I don't want to break any code of conduct here, so let's just, I knew it. Yesterday was not good either, but we were like, okay, let's just hope for the best. Okay, PM start. I think here is hard-coded. The day 2 is hard-coded. It's going to be okay. Okay, so this game, okay, first word, what it can be? Star. Okay, next word? Word, that's easy. Okay, this one? Clone. Good guy. There we go. This application, notice that when I click, it has some sort of animation. It comes there. This application, when I first open it, it downloaded very, let's see, no, this actually, downloaded the JavaScript for some sort of like SPA navigation. But even this application, if I go here and say, even if I completely disable JavaScript, I'm not even talking about we download little JavaScript. It's even with the JavaScript disabled, there is no executing JavaScript. There is nothing being executed. I can still use this game. So, and I didn't have to do anything special. The only way to build this application in Qwik will actually give you these things. So even if the JavaScript was so slow that the network, you could even play this game. So, but notice that there is no anymore this animation. In fact, every single time that you go, it will be like a fast rephrase that was rendered in the server. Again, I want to pay attention that you didn't have to learn any trick. So I'm not going to teach you how to do this. You will just get it. Another, oops, okay. I closed it, okay, that was fast. Okay, last demo, how am I going with time? Okay. It's something very, very cool. I was very excited. It was one of the last things we had in the last release. And I think it's very, very sweet. So I'm going to close this because I'm going to mess this. Rumpler. OK. I closed too many things, actually. OK, I think it's this one. Yeah. So this little app is the same one, but I have already something ready. In a second. OK. So I'm going to add one image. So I have one image in the public directory, Thunder PNG. So I'm just going to make a new image here. Just going to, nothing special. I'm not going to use any component, just Thunder PNG. When I get like a little thing saying that, well, there is a better way to do it, but you know how we are. Like, we are just lazy. The first thing you will do is probably disable DSLint and get the thing done, right? So this is not the thing. This is not the demo. So I will just open this and see what happens. Oh, we are in development. We get a little warning. If we click here, OK, I'm going to actually save and git, so we see the difference, what happens. So I click here, and it will tell me there is a performance issue. It's a layout shift. A layout shift means that this image actually doesn't have the size, so when it's not loaded, it will actually move the screen, and that will affect you actually in a very bad way, your performance. In addition, if we look at the network tab, I'm going to refresh, I'm going to see images. We see that this image is huge. It's 1.7 megabytes. I don't know if you can see it here, 1.7. What I'm going to do is click here again. I'm going to say out of fix. So nothing changed. But now the image is 29.9 kilobytes. And if we inspect what's going on, we'll see that this image is actually using a source set. So it will actually optimize the images for different sizes. It will write the use attributes. It will actually set the width and height. So even when the image is not loaded, it will still not cause layout. And this just, we still have to do a little work, but we just do it for you, because we know that otherwise you will not do it. So the change it did was actually changing the code. It changed the code for you. There's a little bug here. So it actually found a better way to do it. And we will try to do this with more things, even with Google Analytics, how you put this script there, how we use it with a project we have also called PartyTown, which can optimize these things. We'll do it for you. All these kind of things. But when we get to the point that we really need the developer to do something because we cannot find a better way to solve it automatically, we are thinking about how to change it. So that was the last demo, but one more thing. In about 7 days, we are going to release one of the more interesting projects I work in my entire career. I really recommend you, I really ask you to take your phones right now and scan this and put your email. This is going to change how front-end developers write code, how the conversion between design and actual code. We are going to show very, very cool things, and you should really be on top of this. I also make cool memes, videos, and Twitter, so please follow me. And that was it. Thank you very much.